morning, everyone. So now that you've finished your notes on weathering, erosion, and deposition, the next thing we're going to do is Bishop Creek Lab. And this lab I intended for you to start by this Wednesday and then be able to finish up by next Wednesday. So you've got a week to do it, but I want to walk you through what you're going to be doing every day. So there's two goals for the lab. The first is you're going to be examining samples of sediment from several places along Bishop Creek. So Bishop Creek is the creek that flows through town. It starts up all the way in the mountains, and then it flows down the hill into Bishop City Park. You've probably seen it if you went to the visitor center to see the ducks. And we're going to be recording our observation. Now, by sediment, when we're looking at the samples of the sediment, we're looking at pieces of rock. So anything from big pieces of rock to little sand and clay, and we're going to be recording our observations about those pieces of sediment. The reason why is there's a relationship between three things: how fast the stream is flowing, the size of the sediment, and the minerals that we find in the sediments. So we're going to look at those three things and try to figure out how can we predict how big the sediment would be and what minerals it would have if we know how fast the stream was flowing. So when you go to your lab right here, at the top, this is where you're going to put your name. It's always a good idea to make it clear who's doing it. And then these are the goals that we just went over. Now on here, anytime you come to a green blank, this is where you're going to be filling it in with your own work so that I can see what you've learned. So the next part right here is to review your vocabulary. You can look at your notes or this video, and you're going to be writing down what weathering, erosion, and deposition are, because it says sediment can be weathered, eroded, and deposited. So going back to our slides, sediment is clay, sand, pebbles, boulders. It's any size of rock. Weathering is when that rock is broken into pieces. Erosion is when those pieces of sediment are transported. And deposition is when the sediment is dropped in low areas like a river, a basin, or an ocean. So when you come back to your lab, you can put weathering is when rock is broken into pieces like that. So go ahead and fill in the definitions right here. The next part is there are three questions. When can water carry or erode the largest pieces of sediment? When it's moving fast or slow, and why? So think about when does it have enough energy to be able to move big boulders and rocks, when it's moving fast or when it's moving slow? If water goes faster, what happens to the size of particles it can carry or erode? Can it carry bigger ones or smaller ones? And what size is deposited? So what size can it not carry? As water slows down, what happens to the particles of sediment that water can carry or erode? And then what size is deposited? So going back to our key ideas here from yesterday, we said that the largest particle that water can transport depends on the speed of the water. Fast water has lots of energy, and it can transport large rocks as well as anything smaller. This is showing the Potomac River in New York. You can see it's moving really fast, and it's able to move boulders as well as anything smaller than that. However, when the water starts to go slower and it has little energy, it can't transport clay-sized particles and dissolve loads. Those are the salts we talked about that can get dissolved in the water. And you can see this river is moving pretty slowly. It's full of clay and small sediments, but it's not carrying anything as big as a boulder. So go ahead and use that to answer your questions 4, 5, and 6 on your lab. And when you're done, you can keep going with the video. So to continue with our video, we are going to be looking at samples from 6 locations, starting from Aspendell, which is up the hill from Bishop. It's that little mountain community by Cardinal Village, and ending in Bishop Park in the middle of town. This is a topographic profile going down the creek, and it has estimates of steepness at each location. So a topographic profile just means that it's showing you how steep or gentle the creek is. Now our first location right here where the sediment was taken was at the waterfall, and it was really steep there. The water is pouring off the rocks. A second place where sediment was picked up was at the Forks right here, and it was also very steep there. Bitterbush, it was still steep, but not as steep as before. By the time you get to the intake plants, the stream is gentle. At Walton Park, it's really gentle. And by the time you get to Bishop Park, it's flat. So this is to give you a sense of where the 6 locations are that the sediment was collected, as well as how steep the creek was in those places. So if you look at your lab on the second page, you have this same picture here so that you can see where the sediments were collected from. The next part of your lab is there's 2 tables, and these green boxes means that you need to fill these in. So for sizes of sediments, we're going to be looking at big, medium, and small pieces of rock, and they have specific sizes that are measured in millimeters. Right here, there's a name for all the sizes, so you're going to use this table on your notes to fill in all of those names. So boulders are big rocks, and they can be as big as a house or a car, but when we're comparing this, the boulder has to be as big as from your elbow, so right here, all the way up to your wrist. If it's bigger than that, it's a boulder. If it's not a boulder. Now, if it's smaller than that, if it's somewhere between as long as your finger, so 6.4 inches or centimeters is about as long as your finger, to 25.6 is about the length from your elbow to your wrist, that would be measured as a cobble. Pebbles are even smaller than that. Pebbles are as wide as a pencil, so 0.4 centimeters is about the width of one of your pencils to as long as one of your finger. If it's in between those 2 lengths, that would be a pebble. Gravel is smaller. When we say that it's 2 millimeters to 4 millimeters, 2 millimeters is about the width of one of these phone chargers. So 2 millimeters would be that wide. 4 centimeters would be as wide as a pencil. So if it's in between those 2 sizes, that would be gravel. Sand is smaller than that. Sand is smaller than the width of this phone charger, and it's so small you can see the grains, but it's hard to measure them. But when you rub them together between your fingers, it feels really gritty. Silt is smaller, so when you rub them together, it's going to feel smooth, but you can still see the particles. They're big enough if you look closely. And then clay is where if you rub it, it smells smooth, and it's so small that it's hard to see the individual particles. So you're going to take all these names here, and you're going to fill them in on your lab right here. So take a moment to type in the names boulder, cobble, pebble, gravel, sand, silt, and clay right there. Once you're done, we're going to go over the minerals in the sediments. So there's 4 minerals, and we need to put the names in right here. So here on your slides, we have a slide of the minerals in the sediment, and you're going to fill in these 4 names: rock fragments, quartz, feldspar, and clay. So rock fragments is when there's more than one type of mineral in a single piece. So this is showing a rock fragment, and as you can see all the different colors, it has multiple types of minerals in that piece. Quartz is this. It looks like fractured glass fragments, and it may be rounded. It's clear, light passes through these particles. Feldspar is blocky, orange, cream, or pink. It can be rounded. The light does not pass through these particles. So when you're looking through the microscopes, you're not going to see light passing through feldspar, but you will see light going through quartz. And then clay are very small particles that are too small to identify. We're actually only going to look at rock fragments, quartz, and feldspar, but go ahead and fill in the